Welcome back to this second episode of 12 classes. We're on the second day. Hope you had a great Christmas day yesterday. And today I'm going to be talking about another class that I've enjoyed. It's a maths class and it's called linear algebra. So let's get right into it. So I had a pretty hard time coming up with like a one-sentence summary of what linear algebra is. And so to quote off Wikipedia, linear algebra is a branch of mathematics which studies about linear equations, linear functions, and how we represent them through matrices and vector spaces. And it's a class where I think a lot of people in different branches, especially like physics or computer science or mathematics itself, will have to encounter at some point. It's a very useful class in the sense that a lot of the concepts you do see in linear algebra can be applied to many different branches across science, and for me at least, I keep seeing it again in different classes that I have taken in the past. So what sort of things do we learn, or at least I learned, in linear algebra? Well, first of all, we looked at, linear equations, as I said. So what are these linear equations, and why the word linear? Why not just like any old equation? Well, the word linear, or in both linear algebra or linear equations, basically refers to a very specific case of expressions or specific case of equations, in the sense that we're not talking about variables to the power of 2 or variables to the power of 3. We're talking about variables in their first power, maybe multiplied by some coefficient, all added together, forming an equation or an expression, etc. And so for the first parts of linear algebra, you look at, for example, these sort of equations, linear equations, and you ask, how do we solve them, for example? And maybe if we have a linear equation, we can turn them into a different representation as matrices and vectors, and then how can I go about and solving like this system of matrices and vectors, for example? And then once you start to get more introduced to these vectors and these matrices, then you start to ask what are these matrices and what are these vectors? And then you might start to talk about Euclidean space or just normal 2D or 3D space, and then see what vectors are in these sort of spaces in the 2D world or in the 3D world, and then what matrices represents. Vectors in 2D space might, for example, just represent a point in space relative to the origin. You might have seen vectors being drawn this way as an arrow going from the origin to a certain point in space. Then you can ask, what are different things we can say about these vectors? Or for example, you can add two vectors together, you can scale a vector by some certain amount. If you have a vector, then you can describe it as a sum of a couple of other vectors. So in this case, you can have this vector be equal to the sum of some vectors in the x direction plus some vector in the y direction. These vectors in the x and the y direction can be called a basis vector. If you have a matrix, this matrix can sort of represent a transformation you can do upon your vector. So if you have a vector, you can apply matrix transformation, and then maybe you rotate the vector, or you flip the vector, or you scale it in some different ways. And so you learn about what vectors and matrices sort of represent, especially in 3D space. But then what's more interesting is that then you can take some of the concepts that you've seen in Euclidean 2D or 3D space, and then you can transform it, and then you can look at more abstract vector spaces. Other things which has got similar properties, like being able to add two components, or having bases, or being able to transform between different things. Many different things out there in mathematics has got some of these properties, and hence can be treated as vector spaces, and hence you can use similar bits of mathematics in order to work between them. One example of this might be things like functions. You can add functions, you can scale functions, all these different things, and therefore some of these structures, things like those, can also be treated as vector spaces as well. And you sort of have like a checklist of things that like makes something a vector space, and then you can like verify if something is a vector space or follows like the same properties as like a vector space, for example. And so that's where it like gets really interesting, because many things out there can be treated as vector spaces. One example I can think of off the top of my head that I eventually did see again later on is in quantum mechanics. There is this thing called wave functions, which basically is like sort of something that describes like a particle or a certain object, and these things can also be treated as vectors, and they have like a corresponding vector space, which is called the Hilbert space, things like that, and they have like very similar properties and stuff as well. Now, one thing you do quite a lot in linear algebra is, even if you have like more abstract vector spaces out there, it's a bit easier to draw analogies to Euclidean space in 2D or 3D, because like it's a vector space that most of us are familiar to. You can draw these things. You can't really draw a function, but you can draw vectors. And so sometimes when you think about things in linear algebra, you just think about vectors in like physical space, for example. And then there's other concepts in linear algebra you sort of talk about, things like eigenvectors and eigenvalues, which is pretty easy to describe in Euclidean space as a very special set of vectors which under some transformation just changes in magnitude but doesn't get rotated. And then there's a whole bunch of other properties you could get out of it. Another concept that you might meet is the concept of inner products, which in Euclidean space is just the dot product, but in other vector spaces you have different ways of defining what the inner products is, what properties do these inner products have, things like that. And so linear algebra is probably one of the first maths classes where you really like sees some of the spirit in mathematics, where you take a concept and then you somehow find definitions for it to make it more rigorous, to make it more concrete, and then just see what sort of things you can get out of it, what properties you can get out of it, and then see maybe what else can you draw analogies to and stuff like that. And yeah, it's a really fun class that I've taken, and I think one of the things that like I really liked about it is how useful it is, because different parts of linear algebra I have seen in different places, like all around, like in my university times, and I don't think I have enough time to talk about all of those, or at least in this video, because I try to keep it under 10 minutes. So I guess that's all I'm going to mention. There are many good resources if you want to learn about linear algebra. One that I would recommend is not really a textbook, but is a series by 3 Blue 1 Brown, which I think everyone who's watching this channel has probably seen before, because I'd say 3 Blue 1 Brown is probably a little bit more famous than I am, has a couple of more subscribers than I do, so I think I guess everybody have seen it. But if you haven't, it's a very good introduction to linear algebra. And yeah, I think that's it I have to talk about this class today. And yeah, thank you for watching this episode of 12 Classes. I'll see you again in tomorrow's episode, where I talk about something that's a little bit shocking.